In a groundbreaking discovery, NASA's James Webb Space Telescope has identified ethanol, among other icy components, in the vast expanse of space. This find marks a significant leap in our understanding of the cosmic environment and its potential for harboring life. The Webb Telescope, renowned for peering into the universe's most ancient galaxies, has now added a fascinating chapter to its mission by uncovering these icy molecular ingredients. An international team of astronomers used Webb's mid-infrared instrument to identify a variety of icy compounds made up of complex organic molecules, like ethanol and likely acetic acid. This work builds on previous Webb detections of diverse ices in a cold, dark molecular cloud. This finding contributes to one of the long-standing questions in astrochemistry. What is the origin of complex organic molecules in space? Are they made in the gas phase or in ices? As several COMs, including those detected in the solid phase in this research, were previously detected in the warm gas phase, it is now believed that they originate from the sublimation of ices. Sublimation is to change directly from a solid to a gas without becoming a liquid. Therefore, detecting COMs in ices makes astronomers hopeful about improved understanding of the origins of other, even larger molecules in space. Scientists are also keen to explore to what extent these COMs are transported to planets at much later stages of protostellar evolution. COMs in cold ices are thought to be easier to transport from molecular clouds to planet-forming disks than warm, gaseous molecules. These icy COMs can therefore be incorporated into comets and asteroids, which in turn may collide with forming planets, delivering the ingredients for life to possibly flourish. The detection of COMs in ices suggests that solid-phase chemical reactions on the surfaces of cold dust grains can build complex kinds of molecules. The finding came from the study of two protostars, IRAS-2A and IRAS-23385, both of which are so young that they are not yet forming planets. Protostar IRAS-23385. An image of a region of a molecular cloud. The orange cloud is dense and bright close to the top of the image, like rolling clouds, and grows darker and more wispy toward the bottom and in the top corner. One bright star with 6 short diffraction spikes and several dimmer stars are visible as light spots among the clouds. This image at a wavelength of 15 microns was taken by the mid-infrared instrument on NASA's James Webb Space Telescope, of a region near the protostar known as IRAS-23385. IRAS-23385 and IRAS-2A, not visible in this image, were targets for a recent research effort by an international team of astronomers that used Webb to discover that the key ingredients for making potentially habitable worlds are present in early-stage protostars, where planets have not yet formed. Complex organic molecules in IRAS-2A. Graphic titled, NGC 1333 IRAS-2A Protostar, Miri Medium Resolution Spectroscopy. Shows a graph of optical depth on the y-axis versus wavelength of light in microns on the x-axis. The x-axis ranges from 6.8 microns on the left to 8.6 microns on the right, labeled in even increments of 0.2 microns. The y-axis ranges from 0 on the top to about 0.65 on the bottom, with labeled tick marks at 0.2, 0.4, and 0.6. A jagged white line with several prominent valleys extends horizontally. Vertical bands in different colors mark different wavelength regions and are labeled with molecular names and formulas. Of particular interest is that one of the sources investigated, IRAS-2A, is characterized as a low-mass protostar. IRAS-2A may therefore be similar to the early stages of our own solar system. As such, the chemicals identified around this protostar may have been in the first stages of development of our solar system and later delivered to the primitive Earth. NASA's James Webb Space Telescope's mid-infrared instrument has identified a variety of complex organic molecules that are present in interstellar ices surrounding two protostars. These molecules, which are key ingredients for making potentially habitable worlds, include ethanol, formic acid, methane, and likely acetic acid, in the solid phase. The finding came from the study of two protostars, IRAS-2A and IRAS-23385, both of which are so young that they are not yet forming planets. The science team also detected simpler molecules of sulfur dioxide. Research suggests that sulfur-containing compounds like sulfur dioxide played an important role in driving metabolic reactions on the primitive Earth. All of these molecules can become part of comets and asteroids, and eventually new planetary systems when the icy material is transported inward to the planet-forming disk as the protostellar system evolves. We look forward to following this astrochemical trail step by step with more Webb data in the coming years. These observations were made for the JOYS+, James Webb Observations of Young Protostars, program. The team dedicated these results to team member Harold Linartz, who unexpectedly passed away in December 2023, shortly after the acceptance of this paper. The James Webb Space Telescope, launched with the aim of exploring the universe's earliest galaxies, has been instrumental in uncovering a multitude of cosmic phenomena. From the formation of stars to the identification of planets outside our solar system, JWST's contributions have been pivotal. The Webb Space Telescope, a joint project between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, launched on December 25, 2021. It operates from a point in space known as the second Lagrange point, or L2, which is about 1.5 million kilometers, or approximately 1 million miles, away from Earth. The telescope is designed to study every phase in the history of our universe, extending the discoveries made by the Hubble Space Telescope with its unprecedented sensitivity and ability to observe the universe in infrared. The discovery of ethanol and other icy ingredients in space by the James Webb Space Telescope opens new avenues for research into the conditions necessary for life. The presence of ethanol and other icy components in space is intriguing for scientists, as it could point to the molecular complexity existing beyond Earth. Ethanol, a simple alcohol, is a fundamental component in the chemical reactions that lead to the formation of more complex organic molecules. Its detection in space reinforces the theory that the building blocks of life might be widespread across the cosmos. The James Webb Space Telescope is the world's premier space science observatory. Webb is solving mysteries in our solar system, looking beyond to distant worlds around other stars, and probing the mysterious structures and origins of our universe and our place in it.